Morning. This shouldn't have come out. All right. This week too, I'll do manual attendance, but you guys still should do the self one. Jaffer here, Tanner, Rice, Ethan, Brady, Maddie, Jones, Corliss, Lily, Brian, Jacob, and Victoria. All right. Yeah, let's add it. Abacus. All right. Today on Thursday, we're going to build a spreadsheet that's going to calculate present values, future values for an annuity with growing payments. Okay. And eventually, we're going to make the whole thing automatic and stuff. But we got to define what a growing annuity is first. First of all, who's going to tell me what an annuity is? You remember it from your other classes? Come on, some of you took basic finance from me. Yeah, equal set of payments over time, okay? With a finite number of payments. Equal set of payments, I should say, actually, periodic payments for a finite amount of time. I use finite on purpose. When that is not finite, we actually call it a perpetuity. Okay? Now, let's let me say growing annuity. We determine the first payments, C1, okay? Um, payment received at the end of first period, whatever that period may be, month, year, quarter. And after that, payments in period T plus 1 equals payment in period T times 1 plus growth rate, where $CT means payment received at the end of period T, and G is period growth rate of payments. Now, let's use R as period interest rate. When R is greater than G, there is actually a closed form formula. to calculate the present value of a growing annuity. I mean, I'm going to write it, but you should actually forget about it. It's basically, let me see, $C1 divided by R minus G times 1 minus 1 plus G divided by 1 plus R, the whole thing raised to the power T. So let me use curly braces for that. You know, as I said, this is equal to PV. It is an ugly formula, and if you want to memorize it, memorize it. I didn't even want to bother to write it by hand. Uh, this formula works fine when the period interest rate is greater than the period growth rate, but when that is not the case, this would obviously give nonsensical results. You know, it would get something negative, okay? And that's obviously not a good thing. And because it depends on the way you derive this formula, you actually calculate the present value of a growing perpetuity. If R is greater than G, that would be equal to C1 divided by R minus G. You may remember it from your stock dividend growth model, the constant dividend growth. But that formula gives an infinite result when G is greater than R. So we're going to write a function that's going to calculate present value of a growing annuity, whether or not growth rate is less or greater than the interest rate. There are, after all, finite number of payments, so we know the answer is finite. So let's kind of get going with that. I'm going to go to my developer tab and go to Visual Basic. And let me insert a module. Let's call this you don't have to name your modules. It just helps me separate the code. Just for the hell of it, first I'm going to write a function. And let's call this PV1, present value of 1 cash. It has inputs, iCash as double, and I rate as double. I'm going to make frequency a long integer, which means it's a data type that can accommodate up to plus or minus 2 billion or so. And I time is long as well. Technically, I can allow for non-integer time, but I'm not going to. Actually, I'm going to make I time as double. We're going to feed APR as interest rates. So that means I'm going to have some local variables. One of them is going to be P rate as double. And I'm gonna call this iPerry, paying an homage to my puppy love back in freshman year of college. I went to a military boarding school, all boys, so that's not a high school. As long my P rate is I rate, which is APR divided by iFreak, and my iPerry is equal to I time times what you want to call iFreak, just to make sure that this is actually an integer. I'm gonna use an Excel function. Anytime you want to use a worksheet function inside VBA, you start with application dot worksheet function dot rundown. Rundown is a function that runs a number down to the integer below. I want 0 digits, basically. Okay. Sometimes, the function is not available in VBA. I don't think rundown is available, but either way, I get it. Now, what I want to do is easy. PV1 equals iCache divided by 1 plus P rate raised to the power iPerry. Okay.